All right. Hey, everyone. We're just going to be waiting a few minutes while we let some more people join in, and then we'll go ahead and get started. Yeah, we'll give it a few more minutes, and then we'll go ahead and get started. We're going to be talking about AI today. All right. I think I'll just go ahead and get started now. So, welcome everyone to day 2 of the Young Scholar Program, and today I'm going to be talking about artificial intelligence, sort of giving you an overview about what it is, some of the cool applications of it, and some of the cool things that go into what is artificial intelligence and making it happen. So let's see, let me just make sure my screen's being shared correctly. So this is just a disclaimer they put on all of our slides saying that, we're not experts, we're also students, so if there's any information that's not correct, we try our hardest to make sure it's correct, but there's always information that can slip through the cracks, so take all our words with a grain of salt, if you will. Okay, my screen is sharing correctly. So today, we're going to be talking about artificial intelligence. The main sort of things we're going to be talking about are intro to what is artificial intelligence, some of the core concepts of machine learning, deep learning, which I know a lot of people were interested in, fundamentals of NLP, applications of artificial intelligence, and some of the ways you can use it for a business or in a career in the future. And I know a lot of this seems daunting for right now, especially for people who haven't heard of artificial intelligence in the past. But I'll do my best to sort of break it down in a way that it's easy to understand and easy to walk through. And as always, we'll be giving these slides as well at the end of the program. So if you want to ever take a look back at these, feel free to do that as well. So an introduction to artificial intelligence. So artificial intelligence is sort of the ability of a computer to do things that typically require what we call human intelligence. So like let's say we look at a group of people, we're able to sort them into categories, or we look at a graph, we're able to see, okay, it's trending upwards, or it's trending downwards. Those are sort of things that require, some complex reasoning and what we call intelligence. And artificial intelligence is just the ability of a computer to do those same sort of things, creating computers that can think, they can learn, they can make decisions, and enable them to do the things that we can do, like analyze data, recognize patterns, solve problems, and even understand and respond to our human language. A little bit about the history of artificial intelligence is, well, you guys might have been hearing about artificial intelligence a lot in the news lately, with the whole ChatGPT and everything like that. Artificial intelligence is actually a pretty old field. Not that old, obviously, but it started around 1950s, 1960s, especially when Dartmouth College in New Hampshire invented the phrase artificial intelligence during a conference that they had. And then as the sort of years gone by, it's continued to have booms and gain traction, especially in the 80s due to advances the Japanese made, and continuously in booms from then on as new innovations and new groundbreaking ideas and concepts come through. And in 1997, one of the first ways that the world was able to be exposed to AI was when IBM's Deep Blue, which was an AI system, beat Garry Kasparov, the world chess champion. And that's when people started to see that, hey, this is really powerful. This is something that can really change the way we look at our world. So what is the importance of artificial intelligence? Why do people use it? Why is it such a prominent thing nowadays? And the significance of artificial intelligence and its components are sort of broken down into the following. Automation. So AI can automate tasks and processes that were previously done by hand, and it can sort of eliminate the need for a human employee to sit there and do like mindless, like sort of, let's say, data entry or sort of like drawing graphs or doing like basic like, oh, identify is this a dog or a cat. It'd be sort of mindless for a human to sit there and do that for hours, but AI can automate those sort of routine processes. AI can also enhance things. It can make products and services better. It can make like your autocorrect on your keyboard better. It can make your whole just sort of experience using something or being in an area and enhance your end user experience. The next thing is analysis. When we're looking at a large data set, let's say we're looking at the data of every person in your home state, it's going to take ages for a human to sort of process all that data. But AI can process that far quicker than people because it's backed by computers. And it can detect patterns much faster as well. Accuracy. So AI can be trained to be more accurate than humans in jobs. That's just sort of a facet of using artificial intelligence. And ROI, which is return on investment. It's a little bit more complicated to think about, but basically it takes complex data and it doesn't have the same sort of ability to like make mistakes as often or taking pauses or taking breaks as a lot of human components would do when analyzing that data. So you get a higher return on investment by putting your money into an AI system. So what are some sort of comparisons of AI and human intelligence? Human intelligence is just your ability to think. Like if you can think, that's human intelligence. And some of the comparisons between them is computers are much faster than humans, especially in the sort of data analysis tasks that we're thinking about, maybe not so much in the categorization side of things. Artificial intelligence is designed for a few skills though. Like AI systems, while they can be a lot faster than humans, they're usually specialized for a certain task. They're like specialized to, I don't know, label data or take trends from a large set of like data points. But humans sort of have a vast variety of skills. We can do everything that AI can, except maybe not as specialized when it does it. Multitasking. So like I mentioned before, AI, it's difficult for an AI to multitask because it has to learn how to do each one of those individual like responsibilities and has to learn how to do them really well. But we've been doing multiple tasks, multiple responsibilities our entire lives. It's sort of how we're built. It's easier for us to do that. Decision making, obviously we have brains, we have actual experience, we have thought processes, so we're able to make decisions based on past experiences. AI, it's just going to look at hard data, and oftentimes that's not the best way to do your decisions. And your brain is physical, but computers are digital, so they can interact with the digital environment much easier. So these are some sort of trends that have been going on recently within AI, and I'll sort of talk a little bit more about some of these trends later on in the presentation. But some of these trends are like voice and language driven AI. So like stuff like Siri or Alexa, or like stuff like ChatGPT, where it takes in text, it takes in voice as input, and able to do transformations and actually process that information. Stuff in cybersecurity, like protecting sort of databases using cybersecurity, detecting attacks and stuff like that, like was mentioned yesterday in Pablo's lecture. Digital business automation, automating the sort of point of sale services, data analysis and stuff like that. And AI for IoT, so stuff like Google Nest, plugs, the Ring doorbells, everything that you sort of see and new gadgets you're getting around your house are all being powered by AI. And it's really, really cool to see that. And currently the sort of market for AI, you could say, is around like $100 billion, but it's only expected to grow exponentially year in, year out, ultimately almost reaching like $1 trillion by the end of 2030, which is really, really cool, especially for you guys who are just getting into the industry or just getting started with your careers in the future. There's a lot of growth here, and there's a lot of opportunity here as well. So we've been talking a little bit about some of the uses and advantages of AI, but let's talk about one of the subsets of AI, which is machine learning. So AI is a pretty broad category, but it encompasses a lot of things. It encompasses like deep learning, machine learning, natural language processing, large language models. We'll talk about all about these in like this presentation or later presentations. But think of AI as sort of general category that wraps all of them in. And machine learning specifically is the study of computer algorithms, stuff like code that can improve and automatically improve itself through the use of data. And it's a subsection of artificial intelligence. And machine learning models, the way they work is they build a model, they sort of build themselves up based on sample data, and they train themselves on that, and they do that in order to make predictions or decisions on new data that they've never seen before. I'll talk a little bit more about that, how that process works now. So the first step of machine learning is supervised learning, which is where inputs, training, outputs. Then there's unsupervised learning and reinforcement learning. And I'll sort of break down what each of these categories mean. So the first type, supervised learning, is a sort of type of machine learning where we provide sample label data. So we provide information to the computer, and we tell it, all right, here's all this data, here's how it works. And then it trains itself on the data saying, okay, I understand this data. Now that you've given it to me, it labeled, and it learns how to make those labels or make those predictions on its own. So like an example of how this would work is, let's say you have a machine learning model and you're trying to train it to distinguish between what is a cat and what is not a cat. So in the first sort of step, you give it a bunch of images of cats and stuff that's not cats, and you label them as, all right, cat, cat, not cat, not cat. And you feed that into the machine learning algorithm, and it trains. It learns continuously. You keep on training it. And then eventually, after you trained it enough, you want to test it. You want to test them all out. You want to see, hey, I've given it this training data. Now, what if I give it a new image and I tell it, all right, is this a cat or not a cat? Can you figure it out? And that's when the sort of second step came in. So you gave it label data, you trained it, and now you give it these new images. You tell me, all right, which one of these are cats and which one of these are not cats? And you see, all right, did it get it correct? Cool. Then our AI algorithm is complete, or we have a certain amount of accuracy to it. If it didn't get it correct, then tune the model a little bit more, continue refining it, continue training it, maybe add more training data. And then keep doing that so you sort of get the model that you want. You can identify what's a cat and what's not a cat. And the sort of most common use cases of supervised learning is stuff like classification. So cat or not cat, classifying emails as spam or not spam, like in your email inbox, and stuff like regression. Regression is a little bit of a complicated term, but essentially it means measuring predictions measuring trends and predictions in the future of data. So like, what's the value of $1 going to be in the future? What's the price of a house going to be in the future, given all this like 20 years of historical data of the price of the house, or the impacts of a diet based on how much food you're sort of intaking over time. Some of the advantages of this supervised machine learning are that it's used for accurate class identification. So like the label cat or not cat, it can do accurate predictions. It's pretty easy to define, like, okay, this algorithm did good, because you can just see, all right, how many images did it identify correctly? How many did it not? Or something along those lines. And you have a lot more sort of control and algorithms at your disposal, because you're giving it labeled data. You can tell it explicitly what to look for, and you know what it's going to sort of output, what it's sort of going to ultimately train itself on. Some of the disadvantages is you have to have labeled data. So there aren't really a lot of places where you can just grab images of cats and have them be labeled as cats. You're going to need either like some sort of human labeling or something like that. You're going to need the ability to actually have that data labeled, which can take a lot of time, a lot of manpower, a lot of money. And you need like really high quality data as well, because you're training it just on this data. So because that is a lack of flexibility, and it can overfit, or essentially you can give it too much training data and it won't know how to deal with any new data because it's just only going to look at its own training data. So those are some of like the cons and downsides of using supervised machine learning. The next sort of machine learning type is called unsupervised learning, which is essentially trains the machine using labeled data and allows the algorithm to work without supervision. So its main sort of objective is, unlike the supervised learning where you give it labeled data, here you're just giving it unlabeled data and just saying, all right, figure out these sort of interactions on your own, figure out these sort of groupings and everything like that on your own, and we'll see what it comes out with. So a sort of example of this is, let's say you have a group of images, let's say a group of animals that you have here, and you want your machine learning model to sort of distinguish them into groups. You don't really know what those groups are going to be. You don't know what it's going to base those groups off of, but you just want it to split this data up into groups. So here, you just give it a bunch of images, and in our case, these are images of birds and cats, but the AI model doesn't really know that because you didn't label any of these. These are just random images that it has of birds and cats. So you feed it in this data, and you allow it to train on this data. You allow it to sort of make its own distinctions, make its own groupings, and you want to see what it comes out with. And ultimately, at the end, you can run the AI model on new data and see, all right, what did you sort of group on? Like, what was that sort of grouping that you graded? And let's say in this case, it just figures out, okay, these sort of cat images, like the images that have ears and the images that have sort of noses and have those sort of two eyes that we can distinctly see, I'm going to group those images together. And the ones that have the sort of beak, maybe like shorter legs, and they have a sort of distinct like bird shape, I'm going to group those together. And at the end, it doesn't know that they're cats or birds. It just knows that, hey, these images on the top, these look similar, and these images on the bottom, these look similar. And it's able to group between cats and birds without you ever actually telling it that those are cats and those are birds, and those are two distinct groups. So that's pretty cool. That's a pretty cool use case. And that's sort of one of the most common uses of unsupervised learning. It's this thing called clustering, which is just what we did above, identifying similarities in groups. So like one of the actual big use cases of this is, let's say you want to feed it on like a bunch of sort of like cells or medical data, and you feed it on like sort of images of cells or something like that, then it can learn to distinguish between, hey, this group of cells and this group of cells look different. I don't really know why, but these two cells look different. And if it's able to make these sort of small distinctions that humans can't make, then that could help us identify, hey, maybe that group of cells on the top that I identified is actually cancerous cells, and the group of cells at the bottom are the normal ones. So it can learn to make these sort of groupings that we would have never thought of because they're unlabeled. It's just making these assumptions on its own. And this is sort of re-explaining what I was talking about with clustering, where you group a set of data or a set of points into individual groups so that data points in a similar group are more identical to another. So you categorize, let's say, this group of like baseballs, tennis balls, and soccer balls on the left. The AI doesn't really know what these are, but it's like, all right, let me just group these together. And it can categorize this sort of population of sports balls on the left to soccer balls, tennis balls, and baseballs just by noticing patterns and similarities between them. Like, hey, these all have this distinct shape. These all have this distinct shape. These have this distinct shape. So we'll identify these sort of patterns and just make these groups on its own without us having to actually label any data, which is really powerful. Some of the advantages are discovery of hidden patterns. So it's not necessarily all as like cut and dry as the ball example we just gave. Sometimes it can identify patterns that maybe even we can't see as humans. It's flexible, it's adaptable. It can find sort of anomalies or sort of differences that are sort of outliers that maybe we didn't think of. And it's really scalable because you don't have to provide labeled data. You don't have to like label thousands and thousands of images by hand. You can just feed it images and have it learn on its own. So the disadvantages, though, is with this sort of lack of labeled data, there's not a clear objective. You don't know what it's going to give out. You could feed it cats and birds, and it just randomly mishmash, like groups them into random categories, like mixed cat and birds, or you group them by like, these are all gray animals, like a gray cat and a gray bird. These are all red animals or something like that. Like you don't really know what it's going to come out with, and that leads to like the lack of supervision as well. And because of that, it's difficult to sort of assess the quality of these models. Like you don't know, what does it mean for these models to be right? Like, is this distinction that I made actually helpful? I mean, it did make a distinction, but is this actually helpful? So it's hard to tell the sort of quality of these models as well. And the last sort of example of machine learning types, one of the biggest ones, along with supervised and unsupervised learning, is reinforcement learning. So in just like a little bit of overview of reinforcement learning, it's essentially feedback-based learning. It's kind of similar to like what like parents do, I guess, when we're trying to like when people are trying to like raise a child. It's you get a reward for each thing you did right. Like, I don't know, you did your chores and you got money for that, or you get a penalty for each wrong action. Like you mess up on something and you get scolded for it. That's sort of what we're doing to this sort of machine learning agent as well. We give it a reward for each action it does right and a penalty for each action it does wrong. And it learns automatically with this feedback and improves its performance. And in a way, what we're doing is every time it does something good or like has like a favorable outcome, we reinforce that, or we say, that's a good, you did a good job, here's a reward for that. I'll talk more about this, what this reward means in a computer way. And then everything that it does unfavorably or everything that it does wrong that we don't want it to do, we sort of discourage it, or we give them a penalty for that. And the goal of these sort of agents is to get the most reward points. And so since it's going towards better and better actions, it improves its performance because it knows that good actions get it more points and it wants the most points possible. So let's say in this sort of example, we give it a random input and like just give it like a fruit or something like that. So here we gave it an image of an apple. And the machine learning model, this is like a very generalized example of it, but let's say, for example, it says, that image you gave me, that fruit, that's a mango. And obviously that's wrong. So we say, wrong, it's an apple. So we give it that sort of negative reinforcement, or we give it sort of a penalty, and that it learns from that. And then eventually, if we do that enough, it's able to say, all right, now this image, I know it's not a mango because when I said it was a mango, I got a penalty because of that. So now let me say, is it an apple? And it got it correct. So now it knows, all right, if I see that image is an apple, I get a reward for that. So that's a good thing. And a lot of these sort of reinforcement sort of machine learning models are used in video games. So it's the way that all those sort of CPUs or computers that you're versing against in video games, like, I don't know, Super Smash Bros. Or something like that, they're learning based on this reinforcement learning. They train them on each other, train them against each other in a way to say, all right, this sort of behavior that you're doing, that's good. That's a good behavior. And this sort of behavior doing, that's a bad behavior. And by sort of fine-tuning those models and fine-tuning those sort of parameters, it's able to make models that can learn to do the most optimal moves, the best moves. That's why those CPUs are so good in video games, because they've been trained to do the best moves, have the best sort of chance of winning it every single time, because that's what they got rewarded for in the training. And there's sort of two categories in which reinforcement learning is used a lot. Is one, in exploration. So let's say you have this like robot here, and this robot here is trying to decide on what restaurant it wants to go to. It could go to the usual place it's always been to, and it knows it will get like maybe a +1 reward point for going there. Or it could go to this new grand opening restaurant. And if it does, it has a chance of losing a lot of points, but it could also gain like +5 or +10 points. So it's sort of making that decision. And if it does go there, then it can get reinforced in that behavior as well. Or exploitation, where it decides, you know what, I know that I'll get a +1 point here, and I don't know what I'm going to get here, and I'm too scared to actually try. So I'm just going to keep going to my usual restaurant. And those are sort of the two caveats, the two main facets in which reinforcement learning, machine learning models fall into. All right. So what are some of the advantages of this reinforcement machine learning? So optimal decision making, because, well, it's being trained to do the best things possible. It's versatile. It's autonomous. Like you're not really telling it to do anything. You're just sort of setting up these rewards and penalties in advance and letting it rip and just seeing, all right, where is this going? What is this doing? And it's pretty much learning on its own. You don't have to do much for it. And it's adaptable to different environments. You could throw the models into different environments, give them different sort of rewards and penalties based on the behaviors you want. And it keeps improving upon itself. It keeps trying to go for higher and higher scores or better and better sort of rewards. But some of the disadvantages of this are that it requires a lot of compute power. Like trying to train these models to handle all this input data and all this sort of rewards and models and stuff like that, it requires a lot of compute power. It's very sensitive to like the parameters, sort of rewards, penalties. If it learns that it can take like a -10 penalty to get a +20 reward versus taking a +5 penalty, the way you sort of set those things up can very quickly change how the model behaves. And it's hard to sort of explain the rationale behind some of its decisions. You can say like it's going for the most optimal route, but you don't really know how it's figuring out what that most optimal route for itself is. And that's one of the hard things about it. It's hard to sort of tell what it's doing. But in general, the sort of importance of machine learning, using all these three sort of ways of using machine learning, is it provides people and organizations insight into sort of trends and patterns and development of new products that they couldn't have just by using human power. So it provides a sort of insight that we can't think of or we couldn't come up with because it would take too much time, too much effort, or we just don't have the insight that AI does. In general, the sort of steps of machine learning, like across all of the sort of supervised, unsupervised, and reinforcement learning, is collecting data, preparing data, choosing which one of those three types of models or which one of the submodels within them you want to do, training, evaluating, which is saying, all right, how good did this model do or how bad did the model do, tuning the parameters. So what I meant by parameter tuning is all the sort of like rewards, penalties, some of the intricate math that goes into these machine learning models, everything like that is controlled by parameters. How much you want to train, how little you want to train, how much of the training and sample data you want to have. There's a bunch of different small like numbers and customizations you can make to the model in code that can change drastically how the model performs. So tuning those parameters can help you make a significantly better model than someone else who has the same data, same model, but just change the parameters in a different way. And at the end, the goal of all machine learning is to make predictions. And so that's what it does. So what are some of the things in the future of machine learning as well? Maybe web engine search results that are accurate. So right now, you might think that Google is like supremely accurate. It's pretty hard to get sort of anything better than Google. But then if you try the new sort of Bing GPT or something like that, or ChatGPT, you notice it gives you results that are very, very specific to what you want, not just in general, here are things related to your topic. So there's a future where maybe your search results are even more accurate than they are now. Quantum computing, which is a really cool field for the future. Maybe there's a potential for AI to generate its own data and then learn on that, which would be kind of like Terminator style, but pretty cool. An increased amount of data, precise sort of customized machine learning models, maybe to like really specific use cases, like in the classrooms and stuff like that. There's a lot of really cool things in the future of machine learning, and it only keeps growing. As you've seen with the last like 8 months, how much AI, machine learning, and sort of the use of AI has grown. And now, like you mentioned before, where we had that graph where it showed artificial intelligence is sort of this large encircling area, and there's machine learning. There's another component in that circle called deep learning, which is sort of a different facet of artificial intelligence. I can see here. And deep learning it's sort of a way of training your computer, training the artificial intelligence, training that sort of model to mimic the way our human brain thinks. Like not just make it like a specialized thing for a certain task, but actually mimic some of our human brain processes and get some really deep insights and really sort of transformative outputs from the model. And it consists of sort of these layers of things called neural networks, named after, well, our brain. Our brain has millions and trillions of neurons going through them, and they're sort of connected in like a web of patterns in our brain. We're trying to simulate some of that with these things called neural networks in computers. And we sort of input data. There's sort of hidden layers in between where it's doing sort of calculations and processes that we can't really see, and then it gets an output. Same way, like when I'm looking at my screen right now and I see that this background color here is purple, I don't really know what process in my brain makes me think that that's purple, but I know that I'm looking at the screen, that's my input, some sort of hidden layer process is going on in my brain, and it's outputting me saying that this background color is purple. So it's that same sort of vein of things of input, hidden models, and outputs. So why does deep learning matter? Like, what is deep learning? We have supervised, unsupervised, and like reinforcement learning. Why do we need this new thing called deep learning? And deep learning is how we get really, really intricate and really, really useful machine learning models. So if you want stuff like self-driving cars, or you want lifelike robots, you want robots you can actually speak to and interact with, and they can move around in their environment. You want convincing chatbots like ChatGPT. That's where you need these sort of deep learning. You need really, really, like, just really, really powerful and really, really intricate models to do these sort of complicated tasks. And it helps machines in improving their ability to recognize patterns, objects, and barriers in ways that normal machine models like the supervised, unsupervised, and reinforcement learning just really can't. And the way that it works at a very, very high level, like very, very high level, is you have these sort of like artificial neural networks, which, like I mentioned before, is just ways, like connections of data and sort of graphs and complicated math that are connected and interwoven in a way that it sort of simulates the neurons in your brain, or to simulate sort of a connection of, hey, I'm passing data from here to here, and it's passing back here, back there, back there, back there. And it's doing that in a way so it's like doing calculations at each point to ultimately end up with an end goal. And they use a combination of sort of input data, certain weights at each point, like, hey, I have 10 data points about like the sort of environment that I'm in. Like, this is the color of the traffic light, this is the speed I'm going at, these are the cars in the lane next to me. How much do I want to weigh each factor in deciding whether or not my car presses accelerate or presses the brake? So, there's a red light, there's a lot of cars around me, and I don't know, I'm like going 20 miles an hour. The fact that there's a red light in front of me, that's weighted a lot. I know to press stop, something like that. That's a very sort of simple example of it, but there's a lot of intricate data and intricate weights and sort of numerical math that goes into how we sort of emulate the human brain, or just not the human brain, but more like human decision making in a way for these sort of deep learning models. And all these sort of neural networks, these inputs, these weights, these parameters, all that sort of stuff works together to accurately recognize, classify, and characterize data based on the surroundings. However, with this sort of new deep learning, there comes a lot of limitations, which is, first of all, it needs an extremely large amount of data, like exponentially more data than any of the other models require, because we're trying to do so much more with it. And with that much data, it's very costly to train these models. Like, usually only big corporations or sort of people who have access to very, very powerful, like industry grade, like graphics cards or something like that, can train these sort of models. And with all these complications, it's not as simple as a lot of sort of plug and play machine learning models we have today. It requires a lot of intricate knowledge. It requires training. It requires the ability to choose the tools you need for your task. And it's less user-friendly for people who are just getting into it. And it's even hard to like look at the output of it. Like, if you're inputting a bunch of data as numbers and it's outputting a bunch of data as numbers, you have to be able to understand what do those numbers need and how can I use that for actual useful insight for humans to read. So some of the comparative like assessment of like what's the differences, what are the advantages and disadvantages between machine and deep learning is machine learning is the sort of workflow of machine learning is it's relevant features, not necessarily from images, but it's relevant features being extracted from a data set that you're given it. But deep learning is sort of automatically extracting this information from the data. Machine learning is restricted in its performance because you need to expand how much training data you give it in order for it to do even more output data or even more sort of breadth of output data. While like deep learning, the more data that you give it, the sort of performance sort of exponentially scales from there. However, machine learning, in order to actually work, requires a lot less data. For deep learning, you need a lot of data just to get a functioning model out there. Machine learning is less accurate, it takes less time to train, and it can train off your CPU or your GPU, while deep learning is very accurate, but requires a lot of training and very, very high compute power. And there's just some different examples of how machine learning and deep learning can tackle the same problem. Like given a set of images of cars, identify what type of vehicle it is. And here you can like manually say, all right, these are cars and these are cars, and train yourself on that. Versus for the deep learning, you have to give it a lot more images. They can just learn to identify, hey, you know, this group of pixels that kind of looks like a windshield, that means it's a car, and learn that it's a car from there. So that was a lot of information, but that was also to going over machine learning and deep learning, some of those examples like that. So going back to this sort of large chart that we had where we had artificial intelligence as the grouping category, our first sort of step into that was machine learning, which was just a general supervised, unsupervised reinforcement learning. Within machine learning, we had that subcategory of really specialized machine learning that requires a lot of data and to simulate the brain processes, and that's deep learning. Now, on the other side of things, let's say we don't want to work on like images, or we don't want to work on, you know, just data trends or anything like that. We want to work on text. We want to work on language. We want to work on our speech. That's where we get to what's called natural language processing. And natural language processing is very specialized. And what it's specialized for is it's how computers, it's how your phone, it's how everything that you use around you interprets and acts on your language. It's how your Alexa identifies what you're speaking about. It's how your Siri identifies, hey, you want to text this person this message? Cool. It's how sort of any sort of computer that you see nowadays that is understanding your speech is built off of natural language processing. And it's a subset of these two categories because it uses some of the same techniques as deep learning or machine learning, but it's specialized to just work on capturing your human language, capturing your speech, capturing your typing input, stuff like that. And it allows computers to sort of comprehend, conduct actions, and communicate with humans in normal language. It's not you give it images or data points and it gives you images or data points or true or false in return. It's you tell it, hey, what is the weather for today? And it returns to you back, the weather for today is 80 degrees and sunny. It's sort of capturing and communicating with language. And if we use for sending orders to operate, translate, like Google Translate, documenting it, your directions and navigation, everything like text to speech, everything like that. So some of the sort of techniques that are used within this natural language processing is stuff like grammar induction, or at least sort of like complicated names for it. But in general, grammar induction is using proper grammar when you're writing, identifying sort of grammar points within your words. Sentiment analysis, which is like, hey, this person is tweeting, I really like cats. And that has like a positive sentiment to it. And this person's tweeting, I feel really sad. And that has a negative sentiment to it. So it's identifying the sort of emotions or positive and negative aspects of a set of text. Aspect mining is a little bit more complicated, but it's sort of identifying like components of your text that are either like favorable, bad, or sort of the emotions related to individual components of your text. And name entity recognition, which is, I don't know, recognizing names, recognizing, hey, you said, I want to find the weather in New York City. Identifying that you said New York City, that's name entity recognition, recognizing that that's a name. And that's what you want to sort of do the weather, you identify New York City, and you know that you want to find New York City weather. So that's sort of name entity recognition example of that. And some of the things you can use natural language processing for is summarizing your text, making summaries of books or literature to sort of condense all the information in a way that we can read it quickly. That's really powerful. Topic recognition, like, what is this, like if I fed an AI model this whole recording of my presentation, will it be able to figure out what I'm talking about and what sort of topic I'm making a presentation about? And speech to text conversion, which you've probably all seen a lot. Like, I don't know, going to Google Translate and clicking the little like volume icon to see how that text is pronounced in a different language, or Siri or anything like that. And since NLP is a subset of machine learning and AI, it uses those same sort of techniques to extract information and learn from it. It just does it. It's just specialized for language. And it learns and sort of continues to learn the fundamentals in the same way that machine learning does. And as a result, it's able to do it's able to guess what the user intends to say. It's able to guess our intentions. It's able to guess the meaning of our words, despite any errors or typos. Like, I don't know if any of you guys have used ChatGPT. You could give it typos. You could like say something really vague. You'll still understand the words and the meaning you're trying to get across, which is what's really powerful. And what's the sort of importance of natural language processing? I'll talk a little bit more some applications as well. And one of the importance is nowadays with social media, with internet, with blogs, with news, there's a lot of data being made available on the internet. But this data a lot of that data is almost entirely text. And if computers can't understand text, and it's sort of unstructured text, it's not like clearly identifiable text, it's unstructured text, it's tweets, it's short form content, it's, I don't know, Instagram bios, it's captions, I don't know, something like that. It's unstructured text, and we want to be able to get information from that. And getting information from unstructured text is a pretty difficult challenge. And there's so much data there that we don't want to let it go to waste. So in this scenario, we can use NLP to understand, parse, and sort of get the key information we need from that data in a way that computers can understand. And it can convert voice to text. People who can't typically write can use NLP to sort of document things with their voice. It can be used in inverse. Someone could type a text, and someone who can't read can be able to hear the text that they're looking at. NLP analysis can assess sentiments of conversations, suggest appropriate responses for people who can't really assess the tone in conversations. It can assist organizations in sort of putting out messages that are more positive, a lot of things like that. And just even more examples like voice recognition, speech to text, summarization, responding to questions, spell check, your grammar check. When you're like typing on your phone and suggesting those new words that you want to like autocomplete to, or is spell checking your document like Grammarly or something like that. That's all using NLP. And some applications of artificial intelligence in general are pretty much everywhere. Look at all of these, pretty much any industry nowadays can have an application with artificial intelligence. And I'm just going to go through some of the really big ones, some of the really cool ones that are coming out. So stuff like digital marketing, so social media campaigns, email marketing, sort of SEO. SEO is when you search up anything on Google, like when you search up, I don't know, X company, SEO is called search engine optimization, which is how I ensure that Google makes my X company show up first rather than anyone else who's named X company. Or if you go Google right now and you search up your name, how do I make sure that my website, my information, my sort of John Smith bio or my Mehar Johal bio shows up first rather than everyone else in the world who's named Mehar Johal? And that's a pretty powerful thing. If you can get your name to be the first thing that shows up when someone searches, like your information to be the first thing that shows up when someone searches your name in Google versus anyone else with your name in the world, that's a pretty cool thing to have. Voice and text-based marketing, other things like that. I urge you all to try that, by the way. Like, look up your name, see if you come up first, see if you come up later. It's a pretty cool thing to see. Defense and military. This is some of the really controversial stuff that people have been coming out. Like, is the world going to go to Terminator if we have this sort of AI technology? But it's good to be aware of it. Using it for better decision making, unmanned vehicles and use of drones, targeting potentials, military robots. It sounds scary, but there are still applications here for artificial intelligence. Healthcare. So on the other side of things, it can be used for helping doctors perform a diagnosis. Like if a diagnosis takes a long time, but an AI is able to do it accurately in a shorter period of time, we can get more people diagnosed. We can help identify what prescription medication someone needs to take. Like if someone says, "Oh, I need this white pill," but they don't know what it's called, we can identify it, like maybe take a picture of it and it identifies what that drug is. It can be used for like nursing assistants online to help walk you through sort of life-saving situations. Surgeries, like actual robots can perform these surgeries. Cars is a really big thing with like Teslas, the self-driving Teslas, self-driving cars. You can 3D print sort of vehicles. You can have smart helmets that can show you your speed, the speed that you're going at, and your directions in like a HUD in front of you, like futuristic Ready Player One style. Autonomous vehicles, machine vision, like your car can like show you the cars to the left and right in your blind spot, or show that it's a green light in front of you. Collaborative robots sort of working around and navigating an environment. You can sort of track your cars. You can monitor the sort of like your car can monitor yourself, monitor your stats, say, hey, if you're being sleepy, I can pull over, and then so I don't cause an accident, stuff like that. The e-commerce industry, how do I, when I'm selling a product, let's say you're trying to start a business, if I'm selling candles, how do I make sure my candles are priced at the best way to get the most people to buy them? That can be done using AI. If you go on Amazon.com and you're scrolling through and you say, wait, I was just thinking about buying dog toys and now I'm getting recommended dog toys. Creepy, but AI, personalized product recommendations. That's a whole other thing, but customer segmentation, identifying which group of customers to show Hey, yeah, my computer just blue screened. Kind of awkward, but yeah, I'm back. Luckily, I didn't have that many slides left, but yeah, that was interesting. Hopefully, you guys can all see me, hear me. Okay, cool. It's back now. Sorry about that. I don't know what just happened, but I'm glad it happened towards the end. All right, let me put this back up. Share screen. Slideshow. Hold on. Okay. It's getting there. Yeah, this is pretty much the main thing that I wanted to sort of going back to what I was saying before. Yeah, artificial intelligence use cases. So how does it sort of how can we use AI in a lot of different areas? One of the last ones that I want to talk about, one of the really big ones that's relevant to you guys is AI is used in education. So let's say you're in a classroom and you're learning and you're really struggling with the topic, but a lot of people in your class aren't struggling with the topic. Or the vice versa. You find something pretty easy, but other people in your class find it difficult. Teachers are sort of short-staffed and they can't customize learning to you like that. But with artificial intelligence, there's the ability to potentially customize this technology, customize the sort of learning to each individual person. It can automate sort of grading tasks for teachers. They have more time to spend on per student. It can tutor students by giving them like one-to-one feedback with an AI chatbot. Learning environments, doing stuff remote, doing stuff in person, and in general, enhancing the way that teachers, students, and education collaborate. Human resources. So this is not as relevant to you guys, but it's something that's still pretty important to think about. Maybe AI can be used for recruitment, scanning resumes, onboarding, training new people who come to a job, enhance your employee experience by giving you another place to talk about some issues you're having with your workplace, and leadership, which is very far in the future, but still. And if you ever want to use if any of you guys are really interested in entrepreneurship, I wanted to include this. And it's how do you sort of assess that you want to use artificial intelligence for your own sort of business? You want to start your own thing. You want to go make your own sort of thing going forward. And you can use our AI with these sort of new business use cases. You can do the same thing where you identify the problems, the solutions that they have. So the scope of the project, and as you learn and use these AI technologies, you can use them to sort of enhance your business process or use them as your actual product itself and assess, hey, what's the success and effect of this product I'm creating, and how can I deliver it in the same sort of timeline? And also, there's a lot of new job roles being created because of AI as well. Stuff like data scientists or using like machine learning or using sort of using AI to get sort of data insights from people, or data analysts, people who either are getting insights from the data that machine learning creates, or actually creating the data that machine learning is trained off of and built off of, creating that data in a way that it mitigates bias and also really makes sure that the AI can get the best results that it can. People who actually develop these sort of machine learning models, they architect them. People who think about problems and how to solve them using AI and what AI applications can have in new industries. There's a lot of new job roles being created as a result of this, and not even all of them have to be STEM related. Some of these can be more sort of problem identification, business oriented problems, and you can collaborate with developers to get the most out of both worlds. You think of the business case, a use case, they can think of the algorithm that can be used to solve it. So it's really powerful how it sort of combines different fields. Or let's say you want to be a doctor and you want to work with an AI technician to make a medical AI product, things like that. And some sort of mixed myths and facts, I think I sort of want to end with this. Some of the myths and facts around artificial intelligence, which are AI is only for sort of large corporations. They can do anything. They can make independent judgments, and that's not necessarily true. You individually can benefit from AI. Small businesses can benefit from AI. Um, AI can't do everything. It needs a lot of data. It needs a lot of good quality data. They can't just make independent judgments on their own. They have to be trained to do things. They're not going to replace all human jobs. They're sort of going to enhance them, create new career opportunities, like I showed before. And also, there's some jobs that just, for the foreseeable future, AI cannot do. And that people will be enslaved by AI robots, and there's not going to be rise of machines, at least not within our lifetime or within a very long lifetime. Yeah, with that, that's sort of all I want to talk about in the presentation. Thank you guys for attending, and any questions? I'll start answering those questions now with a few minutes that we have left. What exactly is a parameter in AI? So a parameter in AI is, so a lot of AI is built on math. Like it's intricate math that computers use to take data and make their sort of calculations and stuff based off of it. A parameter is, think of it like a variable in one of those calculations. So let's say you have like your typical like y equals mx plus b type like math line equation. You have like your slope as a variable in that. In that same sort of vein of things, when AI is doing its math calculations, when AI is doing its doing its computations, each one of those variables in those calculations is called a parameter. And so by changing the value, like let's say your slope, or changing the values of different things in those calculations, or changing those parameters, we can get different results or get more fine-tuned results from the AI. How would you go about finding a job in the AI industry? Finding a job in the AI industry is similar to finding like a job in any sort of field. You can go look at companies or products that really interest you and start applying towards those. But I'd say if you want to really like get your foot in the door, then just start looking and building things on your own. Because you can read about AI, you can do classes and stuff like that. But until you actually get your hands dirty and start, I don't know, building something simple. There's a ton of like websites and places like there, like Kaggle is a pretty big one. I forgot the exact URL, but if you search that up, it should come up. And it gives you a lot of interesting data sets, like everything from COVID-19 to Pokemon classification to what type of like pizza topic is the most popular. It has a bunch of different data sets about things like that, and notebooks that people have already created to actually make these AI models. It's a really good way to get started on learning how to use AI and learning how to use some of these models. And once you get your sort of experience and you learn what you want to do with that, you can sort of see what type of field you want to go into, or what type of companies you like, and sort of applying towards those. Someone just asked, what kind of coding language is used to maintain an AI, if at all? That depends a lot on how you're sort of implementing it. So AI can be implemented in pretty much, for the most part, any language. Some of the really big ones that you'll see, especially as you're starting out, is Python. Because there's a lot of open source libraries that let you do AI really quickly within Python. So I'd say if you're starting out, that's probably a really good place to look. But there's AI implementations in almost every language, because in the end, it's just math and inputting data. And that's sort of a fundamental thing of any programming language out there. Any last questions? Yeah, so some takeaway topics from the presentation, I guess, are first that artificial intelligence is just a computer's way of thinking and making predictions and learning from data. That's what artificial intelligence is. And artificial intelligence can be broken down into a bunch of different categories. Like you have machine learning, where it takes in labeled or unlabeled data and makes predictions based off of that. You have deep learning, where it really tries to simulate the human mind and do really complex interactions and do really complex calculations based on that. Or you have stuff like NLP, where it's using human language and speaking and communicating it to us and understanding our language as a result. And this artificial intelligence can be used in a bunch of different applications and be used as a way to enhance and cultivate and enhance and sort of build new user experiences, to build new experiences and new tools for people. That's what I think are the key takeaways from the presentation. Yeah, I think that's just about time. So thank you guys for coming to the presentation today. I think in about 30 minutes, we'll be talking to someone from Stanford, which would be pretty cool if you want to attend that. Thank you guys, and I'll see you later.